conducting structure will have resistance, inductance, capacitor. Not only it should be solenoid, that one, anything it can be. Even sphere will also have inductance, but we are neglecting it. Time being, at our level, we say that only capacitance and it's having resistance. So here he has not mentioned any resistivity. If he mentions, you have to take the resistance also into picture. So there's no resistance. So only capacitance is what you have to include here. Now, so the problem is very simple. No, it is like just like capacitance CA, CB. So the entire problem so where is the other plate? Can I start problem like this? So what is capacitance CA? CA should be equal to 4 pi epsilon naught R. What is CB? 4 pi epsilon naught R. Where is the other plate? Other plate, let it be at infinity. Other plate, let it be at infinity. So now, which is a charge? This is having a charge. Already we have discussed this problem. Can you remember? These two are what in series? So effective capacitance will be omega square L CA CB by CA plus CB. Then the time period of oscillation is 2 pi by omega. Now we know time period. Find the charge on sphere B as a function of time. At what time charge on Q on B will be Q by 2. And both are having same radius. Both are having same capacitance. In fact, CA equal to CB equal to C, you write it. Then when charge on both the capacitors are same, then potential difference across that will also be same. Now go back to the concept previous class what we discussed. Here charge Q by 2, here Q by 2. Capacitance is same, or say right CA, CB. Then the current through the coil will be maximum, no? Then apply conservation of mechanical energy. Q square by 2C should be equal to Q by 2 square Q by 2 square by 2CA Q by 2 square by 2CB L I max square. You go for one oscillation. Actually, one oscillation, what actually happens here? One oscillation, how do it take place? What you should do for that, you should work out here. This is the time period of oscillation. We got it. In one oscillation, what actually goes on? You have to trace out the set of diagrams. There's no other way. You have to trace out the overall what happens in this system. Like this, I can calculate the Imax. So now this is T equals 0. Very next moment, charge here decreases, charge increases. Then at one instant, I think this will be some intermediate time. So I'll give this is the two is not there here. Yeah. Okay, this two is missing. This is about yesterday we have seen how to calculate that maximum current. Shall I say this is half of time period? This occurs at half of the time period. I think we are making a guess here, no? We have to trace out. We have to trace out all the set of diagrams here. This is the one. The moment I close it. So let me go for, I think I'll get in between. I'll push it on this side. Very next moment, what we get it? Let's see that we have some. after some time. So let this having a charge. Q1 I'll write it, or Q minus Q. I think what best I think I'll write Q1, Q minus Q, let this be Q. A current I1 is flowing. This is a second diagram, or say the first diagram, the initial one. Let it be. This is the one instant of time. So now both are having charge Q by 2, Q by 2. No? So what do you expect after this? The charge of the capacitor, because this is at, there will be some energy in the inductor and also energy in both the capacitors same and charge is same. So after this, the charge on capacitor B will further increase and the current will be flowing. Current will be flowing in this direction. So let this be I3. Charge here will be more than that one. So here you write Q1, Q2. Q2 will be greater than Q1. Nearby diagram, the charge on this will increase. No, what can be finally? Finally, this what happens, no? So it's better you should work out here. So this is what, shall I say, T equal to T by 2. This is what T equal to T by 4, T by 2. Now again this capacitor start discharging. It start discharging. So again the sequence of diagrams. One oscillation, please, you have to draw a diagram. Then only you learn concept. Every problem, what will happen in total one oscillation? The switch is closed. After this, again this will start discharging. Q minus Q, this will acquire a charge Q and the current will flow in this direction. This will be positive, negative. This will be capacitor B will be discharging, capacitor A will be acquiring charge. I'm showing charge only on one plate. Then finally what happens, the charge on both the plates will be equal and potential difference across the inductor will be 0 and the current flowing here will be maximum. This is what time? 3t by 4. Now the charge here will be Q1. It's a similar sequence. Let me repeat. So Q1 greater than Q2 greater than Q1. This is what I1 we took it, no, earlier. Yeah, I1. So this is the I3. And finally it will no current in the inductor. So this is the initial, this one. This is after time t equal to capital T. Able to make it out? There's a one sequence in every problem. Please do work out like this because any conceptual question, so what you do? No mathematics, no, here to help you. What happens in one oscillation? Let him ask anything. You can manage everything that one. Okay, work out this. At what time charge on B is Q by 2? So I think at, where are the diagrams? I'm not seeing. Okay, this Q by 2, T by 4. Again 3T by 4. Twice it will happen, no? Not once. Twice it will occur. So here also exchange of energy will take place the similar way. How the circuit happens, the similar way what happened, it carries on here also. But sir, how come you brought this wire? How come this you brought this wire? This is a hypothetical circuit. Practically, this is a thing. This is only for our understanding purpose. We have do the circuit like this. Is it okay? No. So where is another wire I'm not saying? This is a hypothetical circuit. This is an imaginary circuit which we have brought to understand the concept. So anything comes structures like this, you convert it again into parallel plate only and